Welcome to Esther equation corner. So today I want to resolve this problem. We have root 2 to the power of root x minus root 2 to the power of root y all equal to 60. But let's recall, when we have root of a, this is the same as a to the power of half. So this root of 2 is the same as 2 to the power of half. So imputing this over here, we have 2 to the power of half further raised to the power of root of x minus 2 to the power of half further raised to the power of root of y all equal to 60. So from here we'll be multiplying the powers to have 2 to the power of 1 over 2 times root x minus 2 to the power of 1 over 2 times root y all equal to 60. So this will give us 2 to the power of root x over 2 minus 2 to the power of root y over 2 all equal to 60. Let's name this power root of x over 2 to be equal to m, and let root of y over 2 to be equal to n. So we'll be replacing this with m to have 2 to the power of m minus 2 to the power of n all equal to 60. So looking at this equation, we can observe that m is greater than n. So if m is greater than n, let m be equal to n plus k, provided that k is greater than 0. So this equation becomes 2 to the power of n plus k minus 2 to the power of n all equal to 60. So applying the index law, since it's adding, this is the same as 2 to the power of n times 2 to the power of k minus 2 to the power of n all equal to 60. So we'll factor out 2 to the power of n out. We have 2 to the power of n times 2 to the power of k minus 1 all equal to 60. So from here, some of the factors of 60, we have 60 to be 1 times 60, we have 2 times 30, we have 3 times 20, we have 4 times 15, and we have 5 times 12. So we'll be considering all these from case 1, case 2 to case 5 to see which value will give us a solution for this equation. So for case 1, we have 1 times 60. We have 2 to the power of n times 2 to the power of k minus 1 all equal to, we'll be replacing this 60 with this. We have 1 times 60. But since m is greater than k, we have 2 to the power of n, 2 to the power of k minus 1 all equal to 60 times 1. So equating the left hand side and the right hand side, we have 2 to the power of n to be equal to 60 and 2 to the power of k minus 1 to be equal to 1. So when we consider case 2 is also impossible. And case 3 too is impossible. So we'll go for case 4, 4 times 15. So we have 2 to the power of n times 2 to the power of k minus 1 all equal to 4 times 15. So equating the both sides, we have 2 to the power of n to be equal to 4, and we have 2 to the power of k minus 1 to be equal to 15. So from here, this will be 2 to the power of n all equal to 4 is the same as 2 to the power of 2. So we'll conclude that our n is equal to 2. And for the right hand side, we have 2 to the power of k to be equal to 15 plus 1, and 2 to the power of k is equal to 16. So 2 to the power of k is equal to 2 to the power of 4, meaning that our k is equal to 4. But let's recall that our m is equal to n plus k. So imputing the value of these two, we have m to be equal to 2 plus 4. So our m is equal to 6. So we've gotten the value of m, n, k as 6, 2, and 4. But let's recall that m is equal to root x over 2 and n is equal to root y over 2. So to get the value of x and y, our m is 6. So we have 6 to be equal to root x over 2. Simply means that root x is equal to 12 and x is equal to 12 to the power of 2. So our x is equal to 144. And for here we have n to be equal to 2. So we have 2 to be equal to root y over 2. And our root y is equal to 4. So our y is equal to 4 to the power of 2. And y is equal to 16. So we've gotten the value of x and y to be equal to 144 and 16. So verifying, we have root 2 to the power of our x is 144 minus root 2 and our y is 16, all equal to 60. So we have root 2 to the power of the square root of 144 is 12 minus root 2 and the square root of 16 is 4, all equal to 60. So writing this root 2, we can have 2 to the power of 1 over 2, further raised to the power of 12, minus 2 to the power of 1 over 2, further raised to the power of 4, all equal to 60. So resolving this, we multiply the powers here to have 2 to the power of 6 minus 2 to the power of 4, 2, all equal to 60. So 2 to the power of 6 we know is 64, and 2 to the power of 2 is 4, all equal to 60. So we have 64 minus 4, which is 60, is equal to 60. So the left hand side is equal to the right hand side. Thank you for watching Esther Equation Corner. Subscribe and hit the notification bell so you don't miss out on any of our solutions.